First of all, we're talking about verifying trig identities, so it would be important to know what verifying means. So what's going to happen is, like in Learning Target 3, you had to transform whatever you had to simplify it, right? Same scenario, except you have this equal sign in the middle. So you can have two sides that you are going to prove are equal. So if you don't prove that they're equal, you haven't actually answered the question. Okay? So to verify means to prove that the two sides are equal. So when you start one of these, you are just going to pretend that they're not equal. And you're going to prove that they are.
So these are proofs.
We're not going to call them proofs, because then you will have a bigger temper tantrum than you're going to have in 5 seconds. But they're not proofs. We're just verifying that they're equal. Okay. First thing, some things you should try. These are the things I'm going to use today when I'm doing these. You can transform the more complicated side into the simpler side. So maybe one's this huge ugly fraction, and one is this really simple little expression. So you change the big ugly fraction to the little simple part. Okay? Substitute one or more basic trig identities to simplify expressions. That's what you were doing in Learning Target 3. You were substituting things in, so you cancel things out or whatever. Factor or multiply to simplify expressions. So maybe we need to factor out, like in one of Learning Target 3 questions, a 2. Maybe you need to factor, like as in Mr. Scott says, LOIF, we need to factor that way. Maybe you need to FOIL. Right? There's different things you should be able to do. Multiply expressions by an expression equal to 1. That means maybe you need to multiply by sine over sine. That's 1. Right? Maybe you need to multiply by sine minus cosine over sine minus cosine. That's 1. Okay? And then if you could express all the trig functions in terms of sine and cosine. If you've got a bunch of stuff going on like tangent and secant and cosecant, you change it all to sine and cosine and see if some things happen for you. Okay? But this is the biggest thing you want to remember. Remember, these are not equal. So you prove that they're equal, right? Now, every single one that I give you, you can prove are equal. I'm not giving you a trick question like you can't do it. But because you're proving that they are equal, you cannot add or subtract from each side. You can't multiply 5 from each side. You can't solve, quote unquote, the equation because you don't know that it's equal. So all you can do is like play with one side at a time. You can never move something from one side to the other side. Got it? Okay. So you're not moving stuff around. You're just manipulating one side at a time. Okay? Okay. Yes, I'm going to do a lot of examples today. All right, are you ready? Okay, here we go. First one. So I've got secant squared x minus tangent x times cotangent x equals tangent squared x. All right, so again, I don't know that they're equal yet. We're going to prove that they are. So maybe I start with this longer side because there's more stuff going on and I can make it work. So first of all, I'm going to try to talk through my thought process here. It's going to help you guys out, okay? First of all, I'm looking at tangent x, cotangent x, and I'm like, that's probably going to cancel out somehow. Well, tangent x just tangent x, and cotangent x is 1 over tangent x. So don't those cancel out? Now, they don't disappear into thin air. It's a 1, right? So right now I have secant squared x minus 1 equals tangent squared x. So sidebar over here. Okay. You have this identity that says tangent squared x plus 1 equals secant squared x. That's really close to what this is. Now, with the identities that I gave you already, you can manipulate those all you want. You already know those are true. So you can add and subtract stuff on those all day. All right, because I already gave them to you. I already told you they're true. So like for this one that you already had, I'm going to say, well, I could subtract 1 from both sides.
I thought we weren't allowed to add or subtract.
The ones that you already have, the identities on that page you already have written down, I'm telling you those are true. You can do whatever you want to with those.
So what's the point of the sidebar again?
I'm going to have to use this information in purple to finish this question. You don't have to write it down, but you should know where it's coming from. So I rewrote this identity that I already know is true. Pythagorean identity. And it says secant squared x minus 1 is equal to tangent squared x. Isn't that what that says? That's what it tells us. So in order to prove that this is equal, I have to show that both sides are the same thing. So I'm going to change secant squared x minus 1 to tangent squared x. Now I've proven that these are equal. I've verified the identity.
I was thinking air hockey.
This is the answer. You're just showing the steps to show that both sides are the same thing.
So since there's an identity that says tangent squared x is equal to secant squared x minus 1, that's how you prove it.
It's like going these same calculator. Like
RJ.
office. Okay, so on a test when you put the blue identity thing on there.
No. Like on a, RJ just asked on a test, would you have to show this part over here? No, like all I need to see is that part. I'm assuming you're going to do the other part in your head or to the side or something. I don't know. Is that the only way to do this? No. You could have started with the tangent squared x on the right side of the equal sign and changed it to secant squared x minus 1 in the beginning, and then figure out the 1 on the other side and show that they're both equal that way.
So if you change tangent squared x,
Yes.
and since that equals secant
Squared x minus 1.
minus 1.
Yeah.
That's all you have
So you could have shown steps as well, and it could have ended up saying secant squared x minus 1 equals secant squared x minus 1. That's fine too. You're showing that both sides are equal. Okay?
So what would be an example of, I don't know, they're not equal?
Every single one I'm going to give there. You wouldn't know that those were equal. So you have to write it out. You don't have to write it out. But you have to use it to this problem, yes. I'm just saying the other explained. You could just start with a different side or something. Let's do the next one. Okay. All right. I've got this big mess of a fraction equals 7 times secant theta plus 5 times cosecant theta. I'm going to start with the big mess of the fraction. So I'm going to start over here. Okay. It would be nice if I could cancel the sine thetas out and the cosine thetas, but I can't because there's a plus sign right here, right? So what I can do is split this up into two separate fractions. So I'm going to make a bigger mess before I make it a smaller mess. Okay, so I can split this up, 7 sine theta over sine theta cosine theta plus 5 cosine theta over sine theta cosine theta. So I just split it apart. That's all I did. I've split it apart. So there's not the line on the top. So I can cancel out with the sine thetas in the first part. And I can cancel out the cosine thetas in the second part. Because I've split into two separate fractions. You just have 5 times cosine theta, not 5 cosine thetas. Same thing though. If you had cosine to the 5th power, yeah, you're thinking about exponents. All right, so we have 7 cosine theta plus 5 over sine theta. Now, I just rewrote it without the stuff I could cancel it out. Cosine in the denominator. That's like 1 over cosine. So what's 1 over cosine the same as?
7/7.
Secant. 1 over cosine is the same as secant, right?
Yeah.
So I can change this to 7 secant theta. Yeah. So I get 5 cosecant theta. Well, what do you know?
Are you kidding me? No, RJ, shut up. Get out, RJ, please. You're so smart, why you can... 7 over 4 TV?
That's it. I've proved that they're equal to each other, so I can stop. Not so bad.
It's still based on knowing all
So
this
we
stuff.
have to have a light.
You're not gonna hit me about my
Well, we have another one here.
Questions on the first two so far? All right, comfortable doing another one?
Keep doing them all.
I'm going to do them all. I'm just saying we're comfortable going to the next one. There's still questions. Again, I'm trying to explain my reasoning, and I'm trying to show you different things that you could do that might not have occurred to you to do to begin with. Okay. Next one. Verify that sine A over cosecant A plus cosine A over secant A equals cosecant squared A minus cotangent squared A is an identity. So I'm going to start on the left-hand side again. Anyone want to take a stab at what I might do? One at a time. Right, let's change these into their reciprocals. So cosecant's the same thing as 1 over sine. And secant's the same thing as 1 over cosine. Right? When you divide fractions, you multiply by the reciprocal. So I'm just going to rewrite what I'm multiplying. So I have sine A times sine A over 1 plus cosine A times cosine A over 1. I just rewrote the fractions being divided as multiplying by the reciprocal. So you have sine squared A plus cosine squared A. All right, now sine squared A plus cosine squared A doesn't directly equal cosecant squared A minus cotangent squared A. That's okay. What do we know that sine squared A plus cosine squared A equals? It's one of your identities. Sine squared plus cosine squared equals 1. So we can change this to a 1. Now I haven't actually shown that anything's equal to the other side yet. Sine squared A plus cosine squared A equals 1. It's one of those Pythagorean identities. Now, I have to show the other side is equal to 1 as well if this is going to work. So, sidebar again. That's one of the identities. Okay. There's also an identity that says 1 plus cotangent squared equals cosecant squared. That's one of the ones I gave you, so you can manipulate that one however you want. So if I subtract cotangent, I get 1 equals cosecant squared minus so cosecant squared minus cotangent squared also equals 1. So 1 equals 1.
So where'd you get the 1 plus cotangent squared in the identity?
This is one of those identities that you're supposed to know. Again, they're all a little bit different, so I'm doing all of them. So you can see all these different methods I'm using.
So you just found the theorem that
Right. Okay. How are we doing?
Are we done with this
I
part?
don't think anybody can go do it without
But you're,
having this fixed out.
Well, my expectations are higher than that, so.
Um,
All right, here we go. Flip it over. Yeah. All right, so the first one. This one should be relatively simple. Anyone want to try to tell me what you would do? One at a time. I probably wouldn't change cotangent, cosecant into something else. It would be nice if everything was in terms of sine and cosine.
Identity.
So be careful, because there's changing cotangent to its reciprocal. Now you have tangent that doesn't fix anything. So I'm going to make cotangent into cosine over sine. And then cosecant is 1 over sine. So then you multiply by the reciprocal. So then the sine x's cancel out. So cosine x equals cosine x. Again, even though cotangent could be 1 over tangent, putting tangent into this question doesn't help you. So you try different things, they might not work. That's why one of those tips at the beginning was to put everything in terms of sine and cosine. Sometimes that helps. Questions on that first one? That one wasn't so bad. All right, on the next one. I have 1 over tangent x plus secant x equals cosine x over sine x plus 1. So thinking about some things I've done before, I'm going to split this into 2 separate fractions. Okay?
What number are we doing?
Well, you don't even have to separate 2 fractions. I'm going to change tangent and secant, and it ends up working out. So, all right. What can we change tangent and secant to help us out? Okay, secant's 1 over cosine. And tangent sine over cosine. Again, putting 1 over cotangent isn't going to help us do anything.
Okay, hold on.
1 second.
Okay, so this is tangent. Tangent is cosine or sine.
Tangent sine over cosine.
Oh yeah.
What were you going to say? What do you think the next step is? We don't add those together. Plus 1 over, because when you add fractions, you don't add the denominator. Now you fraction, go back and you multiply by the reciprocal. So you have 1 times cos over sine x plus 1. So you should get cosine x.
Over sine.
1 divided by a fraction. When you divide fractions, you multiply by the reciprocal. So I took the fraction that is multiplied by the numerator, which is 1.
Wow, we got that.
So that's how you got rid of the fraction.
You really
The top part of the fraction.
Yeah, who comes up? Yeah, like how do you? Yeah, who?
Okay. Remaining questions about number 6, or number 5 on yours. Not. Lingering issues. So I've been doing a lot of rewriting things in terms of sine and cosine. A lot of multiplying by the reciprocal. Well, I have 1 in the numerator divided by a fraction. So when you divide fractions, take the numerator or the original fraction and multiply the reciprocal. Other questions on this first one? All right, the next 3 are going to show you some other little techniques you can use if you were trying to get some stuff to happen. Okay? Can I erase this? All right. Next one. Now, if you notice, you have the same trig functions, but one is minus, one is plus, and they're not in the same place. You can't just flip things around. Okay? So again, the first step I'm going to do here probably you wouldn't think of. That's why I'm showing you it now, so maybe you can use it later. Okay? Because there's a negative over here, and there's a positive right here, I'm going to try to get everything out of the denominator as best I can, maybe. We'll see what happens. But I'm going to use almost like what you use the conjugate when you did imaginary numbers in Algebra 2. I'm going to multiply this side by cosecant theta minus cotangent theta. Because that's multiplying technically by 1, right? I'm multiplying by something over itself. So I'm multiplying by 1. You're allowed to do that. Again, this wouldn't have occurred to you to do originally. I get that. Showing you some new things you could do. Yeah, so at the top, I'm just going to get cosecant theta minus cotangent theta, because 1 times that is just what you have. And the denominator, though, I'm going to FOIL. So I have cosecant theta times cosecant theta. That's cosecant squared theta. And I have cosecant theta times cotangent theta. That's negative cotangent theta. So negative cosecant theta cotangent theta. Well, it's positive cosecant times negative cotangent, so it's negative. Then I do positive cotangent times positive cosecant, so I have positive cotangent theta cosecant theta. And then cotangent theta times negative cotangent theta is negative cotangent squared theta. I know this is a lot. But remember why you did the conjugate in Algebra 2 was so that when you FOILed, the middle terms would drop out. So I have negative cosecant theta cotangent theta and positive cotangent theta cosecant theta. So this is 0.
Okay, I'm being calmed up.
Yes.
FOIL.
Mm-hmm. Because you multiply 2 binomials.
I get it. I got it. Okay. Wait, can you hold up?
Yeah.
Wait, do they cancel out? One of them cancel out since there's one on the top?
Because there's minus signs in the middle.
At the bottom of the same thing.
It goes back to
I
one
got a
of,
lot of water in my separator.
yeah, mine goes back to one of,
That's the way I see it.
yeah, mine goes back to one.
You guys, those of you who are trying to cancel out cosecants and cotangents, you can't do that. They're not being multiplied. There's minus sign in the middle.
Why is there an addition sign in the middle of that?
Because we did a positive cotangent times a positive cosecant. So you get positive cotangent cosecant.
Okay.
We had an earlier sidebar, but I'll write it down again. You should know in your head, back of the mind somewhere, that cosecant squared and cotangent squared are in this identity somewhere. So 1 plus cotangent squared equals cosecant squared. And if you subtract cotangent squared, you have 1 equals cosecant squared minus cotangent squared. Well, that's what I have here, and that's what I have here. So what can I replace the denominator with? 1.
Oh, we got some.
What's something divided by 1?
1.
Itself. So I get cosecant theta minus cotangent theta. Cosecant theta minus cotangent theta.
This is wicked and wacky.
Okay. Can I erase this? All right, number 8, or it's number 7 on your paper. I'm going to leave the sine theta, tangent theta. Again, this isn't the only way to do this. So I'm going to start with the right-hand side. Yes, so I'm going to do 1 over cosine. That's going to help me. It would be nice if I could actually subtract those. So what would it take to actually be able to subtract those? Right, you have to have a common denominator in order to subtract them. So I'm going to multiply by cosine over cosine in this one term so I can get a common denominator, just like you would if you had fractions. Because I want to actually be able to subtract them. So you need a common denominator. Just this part.
Multiplying that
Times,
with the side.
yes. So I get 1 over cosine theta. Then over here, cosine times cosine is cosine squared over cosine. But now they have a common denominator. So now I can put it together.
This is amazing. So it's just 1 plus cosine squared.
So you get 1 minus cosine squared. Okay. Now again, if you knew your identities, hopefully you know that cosine squared is one of those identities. Sine squared plus cosine squared equals 1. So I have 1 minus cosine squared. Well, I can make this 1 minus cosine squared. So now in the numerator, I can just put sine squared. Well, I guess this is a theta.
So even though it says 1 plus cosine.
Okay.
How'd you know to do that?
Do what part?
How'd you know to convert to the sidebar?
Because I know cosine squared theta and 1 are in some identity somewhere, which happens to be this one. So I rewrote it to see if I could get it to match. And I can. So I know that 1 minus cosine squared is the same thing as sine squared.
So what do you do?
So you plugged it in.
So I just put sine squared in place. Yeah. So I have a sine on this left-hand side. So I put it in there. I know that I want to have sine at some point. Right? Yeah? Now,
Don't you have tangent right?
almost. If I took a sine out, then I would, right? So if I'm going to rewrite the numerator. If I have sine squared theta means sine theta times sine theta, right? That's what it means. That's what squared means. Over, just one of them has cosine theta. So I guess students say it's over all of it, but if I just put that together, right? Sine over cosine is tangent.
Tangent right there.
And there's the property with that.
But that's all we're trying to get. If you look to the right, left-hand side.
I don't even know where it's from.
That's why you have to look up here. See where you started from.
Get that.
Get what?
But why'd you leave a sign there?
Because I want to be able to get a tangent out of that. So in this step up here, I know if in your head you should know, be thinking sine over cosine is tangent. Well, I got two sines. I need just one sine over cosine to be tangent. So I just separated the sines apart. Okay? Now, if you kept going, all right, if you kept going, there's not much else you can do, but if you stopped up here, so where I highlighted up here, you could have stopped up here, and you could have changed sine and tangent at that point, right? So it could have been sine times sine over cosine. Well, that's sine squared over cosine. So that would have worked. You can manipulate both sides individually.
Can we have done left side?
You could have done left side, but also do some stuff with the right side. You would have to at least get down to here if you did the left side and the right side. I just did the right side. Again, there's some different ways you can do different pieces. Generally, you start with the side that seems more complicated. Like sine times tangent, just multiplication. All I can do is get sine squared over cosine. On this side, either some subtraction, they can change some stuff. There's more stuff you could do. All right, you guys are hanging tight. That's good. One more. That's why you're gonna practice a lot. Okay, one more, and then tomorrow you're just gonna work all class period.
Yes.
All right, the next one. I've got sine A minus cosine A squared equals 1 minus 2 sine squared A cotangent A. I'm going to start on the left-hand side. Why might I start on the left-hand side?
Because it's more complicated.
There's a squared, so I know I need a FOIL. FOIL.
Oh my God, we have to avoid. I'll probably.
So I'm just going to rewrite this so that I know what it's supposed to be, so when you FOIL it, you don't think you're supposed to just square the both of them.
Right.
All right, so sine A times sine A is sine A squared. Sine A times negative cosine A is negative sine A cosine A. Negative cosine A times sine A is negative sine A cosine A, or cosine A sine A. Negative cosine A times negative cosine A is positive cosine squared A. Right? Yeah? These two middle terms do not cancel out because they're both negative. So I've got sine squared A minus 2 sine A cosine A plus cosine squared A. Yeah? I just combined the two middle terms. All right, in my head, again, I'm trying to explain my thinking. In my head, I know sine squared plus cosine squared is 1, right? And there's a 1 over here on this side that I kind of covered up by accident. So I'm just going to rearrange this a little bit. I've got sine squared A plus cosine squared A minus 2 sine A cosine A. I just rewrote it, rearranged it, put the cosine squared towards the beginning. But this part is equal to 1.
Yeah.
Now, I'm not quite where I need to be. I'm going to erase this so you can see. I have 1 minus 2 sine A cosine A, but I need 1 minus 2 sine squared A cotangent A. Well, how can I accomplish getting this sine squared and cotangent if I have sine and cosine? Right, so you could either use this two ways. You could either, at this point, write the right-hand side and simplify some things, which would probably be the easiest way. So Brenda said you have 1 minus 2. That's sine squared A cotangent is cosine over sine. And so the sine, one of the signs cancels out. So you have 1 minus 2 sine A cosine A. That's fine. Okay?